So today we are starting 6-1, Unit 6-1. We have Unit 6-1 and 6-2 left, and then we're going to do a very quick blip on circles, and then that'll be the rest of the material before you take your final exam. Today we're talking about law of sines. Fun fact, this actually used to be part of the geometry class. It's since been moved out of those standards, but I actually learned this back in my geometry class in high school. Before I show you what the law of sines is, we need to go over a few reminders of some very important geometry concepts that we're going to need for these notes. First reminder, Pythagorean theorem which I hope you remember is a squared plus b squared equals c squared, is only used for obviously triangles, but a specific type of triangle. What triangles can you use that formula for? Right triangles only. Good. And I want to establish that because none of the triangles we're going to do today are right, so you can't use the Pythagorean theorem. If I could, that would be what I would do because it'd be a lot faster, but not an option today. Second one, this one's really important. It's one of the biggest concepts to come out of geometry class. The sum of the three angles in a triangle is what number? 180, thank you. 180 degrees. I would spend all year teaching that. Sum of three angles is 180. Third item. And before I write this one down fully, the context for this is going to be a little different. When you first learned these were ways to prove two triangles congruent. That's not how we're going to use them for this class. We're just going to notice how the information in the triangle is arranged. So we had 5 angle/side arrangements of a triangle. And these were a series of acronyms. So you learned 4 of them. There is a 5th one that we're going to talk about in here. First we have ASA, angle, side, angle. SAS, side, angle, side. AAS, angle, angle, side. SSS, all 3 sides. And then this third one I'm going to put in parentheses because you were taught not to use this in geometry because it doesn't work for congruence, but it's going to be a huge component of this unit. We're actually going to spend all of Monday on this topic specifically. The 5th one, and this was the forbidden one to say in class, I think you're going to see why. Angle, side, side. Not a real congruence property, but it is a very important case of triangle to study. So we're not going to see that for sure until Monday. Today, the 2 arrangements you're going to see are ASA and AAS, but you need to be aware of all 5 of these because they will come up throughout the entire unit as a whole. All right. Now that I've given you kind of the 3 points to remember, let's talk about the law of sines. First, let's draw a triangle, and anytime I draw a triangle, I never draw the standard right triangle, just draw a regular triangle. So mine usually looks like this. Something like that. Of course, you could draw it upright if you prefer, but I don't know why. This is just my natural triangle. Let's call this triangle ABC, and when I label these, I always start in the bottom left corner. You can start at any angle of the triangle that you would like, but that's just where I default. A, B, C, like that. So we have triangle ABC here. Its angles are capital A, capital B, capital C. Make sure you capitalize because I'm about to use lowercase in a moment. The sides across from each angle, we can describe them with 2 letters. That's how you were taught to do it back in geometry, side A, B, B, C, C, A. But it is a little faster and easier if we just give it 1 letter. So the side across from A, we give it the lowercase a. Side across from B, lowercase b. Side across from C, lowercase c. So we have sides all lowercase a, b, c. So make sure you're being careful about your capitalization versus lowercase. The law of sine states that in any triangle, this is true. Sine of capital A, sine of angle A, over lowercase a, over side A, is equal to sine of angle B, capital B, over side B, is equal to sine of capital C, angle C, over side C. When you actually use the law of sines, this is what we call an extended proportion, where we have more than 2 proportions involved. You will never use all 3 of these at once because you can't solve an equation like that, first off with 2 separate equal signs, but with multiple things like that. So all 3 of these are equal to each other. You can choose any set of 2, but you will never do all 3 at the exact same time. So I want to clarify that. All right, let's do an actual problem. Example 1, solve the triangle using the given information. Round to 2 decimal places. We are given triangle ABC, little a, so side A is equal to 67. the measure of angle B equals 66 degrees, and the measure of angle C is 30 degrees. So you'll be given 3 parts, and when it says solve the triangle, you need to find the other 3 missing parts of the problem. First things first, let's draw a picture, and I always recommend this, no matter the problem. Triangle ABC. And then sides A, B, and C. And then I'm going to fill in the numbers that are already given. A is 67, that's little a, side A. Angle B is 66 degrees. When you label the angles in the triangle, write the number inside the triangle, not outside. I think that gets a little confusing. So this is 66 degrees, and then angle C is 30 degrees. My strong recommendation to keep you organized is I'm going to write a list of all the things I need to find. And then once I fill that out, then I know I'm done with the problem. So first off, we need to find angle A. That's the only angle that's missing. So we'll find the measure of angle A. And then we're missing 2 of the sides, and I always write them down in alphabetical order. All right, let's solve. The very first thing I'm going to solve for is actually angle A. Does anyone want to propose a method, a way to find angle A? Go ahead. Exactly. We know that the 3 angles together is 180. When you're only missing 1, makes it pretty easy. So you can do this. I'm actually going to show you an even more straightforward way. It's just a slight way to rearrange the math, if you will. You can add both of these together and then subtract it from 180, or you can just do extended subtraction. 180 minus 30 minus 66, whatever's left is your angle. So that's what I'm going to write out just because it only is 1 line for me. 180 minus 66 degrees minus 30 degrees now you can just do all at once in your calculator. (84) is the remainder, so 84 degrees is the measure of angle A. And I completely forgot to mention, so before I move on to the next thing, this seems not important now, but when we get to the end of the unit and we have several problem types mixed together, doing this one little step at the beginning of the problem will be very helpful. Identifying the arrangement of the information, so identifying which of these 5 you have as your triangle, because depending on which scenario you have, it's going to affect how you can solve the problem. So looking here, I have 2 angles with a side in between those angles. So it goes angle, side, angle. This is ASA. if you get in the habit of labeling those now, it'll help come test time. Okay, now that I've went over that, what I personally like to do, this is what I like to do, I will fill in the numbers as I go when I find them, but I mean having the answers over here also works. It just kind of helps if you get stuck. You can see everything you have so far and then kind of figure out where to go. All right. From here, you can solve for B or C in either order. It does not matter. I always go alphabetical order. It's just a consistent way for me to stick to. So that's what I'm going to do, is I will go with B next. And this is going to take up a bit of space on the paper. And I'm going to split this section in half down here because I'm going to have work for B and then work for C next to it. This is going to look a little wonky the first time you see it, but then after that, it's going to be like the same thing on repeat. Next, you're going to find B. This is where the law of signs comes in. Because, reminder, we can't use Pythagorean theorem. Even if we were able to, we wouldn't be able to, where we have two sides missing. So the law of signs can help us out. To use the law of signs, you have to be able to have a matching pair of angle and side for one of the letters. That's the requirement. And I have both A's. I have angle A and side A. So I'm going to use the first proportion here, sine A over A. Equals. And then whatever you're trying to solve for, that's going to go on the right side. I want B. So sine of B over B. And then next, we're going to fill in the numbers that we can. If you can't fill in 3 of these 4 numbers, you don't have enough information to use the law of signs. You'll have to try something else. We have sine of A is 84. Over little a is 67 equals sine of B, angle B is 66. And then little b is what we're solving for, so that will just stay as little b. Anyone got an idea on how we're going to solve this? Any ideas? Aiden?
I'm just going to plug that A section into the calculator and then we're going to do algebra to solve for it.
I'm going to come back to you on that because I think you might be right, but that's not the explanation we're going to go for. Yes? Cross multiply is straightforward. Is that the way you were going with? That's the math you're doing? Okay, just want to make sure. Yes, that would work, Aiden. Yeah, so once you see this a couple times, you'll be able to kind of do this automatically without showing the work. It is pretty intuitive, but it just takes a couple times of seeing it first. Anytime you have 2 equal fractions, cross multiplication will always be an option and usually the most straightforward way. Now, a lot of students overcomplicate this, I promise. Just don't overthink it. This is still algebra at the end of the day. So I'm going to cross left first. I'm going to write, the order doesn't matter, but this helps. Sine of 84 times, I am physically writing the times b. I'm trying to make this as simplified as possible. Equals. Right side, we have 67 times sine of 66. You can technically put them in any order, but I always put the whole number in front. 67 times sine of 66. And I'm going to put that in parentheses just for good measure. Okay, students get stuck here all the time. Let's take it back to the basics. What is our goal? What are we solving for? B. We're solving for the letter B. Variable. How do I get B by itself? Yeah. Yes, this is why I put the times there in case you forget. You just blank because it looks a bit complicated compared to what you're used to. We have multiplication, so the opposite is division. We will divide off that sine of 84 on both sides. So clearly this is going to cancel over here, and we're left with b. b equals, and then fun fact, you can write straight up 67 sine in your calculator. It will understand this is multiplication. So I'm going to drop the times in between those two. 67 sine of 66 over sine of 84. You need to type that into your calculator to get the answer. And then reminder, we're rounding to 2 decimal places. Make sure your calculator is in degrees when you type this in. And if you have this calculator, make sure you're using alpha x, the fraction button. We don't want to mess with parentheses. 67 sine of 66 over sine of 84. And 2 decimal places. 61.54. And now I'm going to find C. Finding C is going to be, it's going to be almost identical to what I just did with B. Pro tip, when you go to set up your final sign, law of sines proportion, I technically have both B's now, so I could use sine of B instead of sine of A to find C. And you can, but just coming from me, I always like to use the given, and especially because even though this wasn't given, it's still a whole number. I like to use whole numbers over something I found and had to round, because when you use an already rounded answer to find another answer that you will have to round, it can just throw off the numbers a bit. So it's always safer to go with whole numbers, given numbers, use those if you have the option. So in that case, I'm going to use A again, and then obviously I'm going to use C on the right side instead. Sine of A over A equals sine of C over C. And aside from one number changing, the math is going to be exactly the same. So I'll go through this a bit quicker. Sine of 84 over 67 equals sine, and C is 30 degrees. So sine of 30 over C. Cross multiplying, we have sine of 84 times C is equal to 67 sine of 30. Divide off sine of 84 on both sides. C equals 67 sine of 30 over sine of 84. And then since I have that basically typed in, I'm just going to take the last entry and edit it. So as you can see, only one number changed from B to C. 33.68 is the value of C. And there you have it. I have completely solved for the missing parts of the triangle. This is my result. Questions on the process, any of the steps before we do that again? Okay. There's only one tiny thing that's going to change on this problem. Otherwise, it's going to be exactly the same. So hopefully after the second one, you're going to feel very comfortable with this process if you don't already. Example 2. I'm not going to write the directions out again, but the same directions apply. I'm just going to give you the given this time. Given triangle, can't see the letters, hang on. There we go. KLM. So we're going to change the letters up all the time. Don't overthink it. Little k equals 1.2. If you're ever confused on if the letter you're looking at is capital or lowercase, if it doesn't have an angle symbol, it's the side. It's going to be lowercase. K is 1.2. Measure of angle K is 83 degrees. And the measure of angle M is 5 degrees. So first off, I'm just going to draw the triangle. And again, I always like to start in the bottom left corner here, KLM. It is literally impossible to label these wrong. You can put the K at the top, on the side, doesn't matter. Just go around in that fashion from there. And then we have little k. For little l, I like to do a curly L just to not be confused with a 1. And then little m. Next, I'll fill in the info I do have. We know that side K is 1.2. Angle K is 83 degrees. And angle M is 5 degrees. And before I get started, this is the point where you want to take a moment and look at what you have and identify the type of problem. Because if this were like a standalone test problem, it wouldn't say use the law of sines. You would be able to tell by the given information to use the law of sines or a different method, which we'll discuss later. So we have two angles, and the side is not between the two. It's not the side that the angles share. So this is angle, angle, side. So hopefully you can see this when I do a comparison real quick. This was the previous problem. The purple, that's why I color code, the purple was the given. Two angles with the side included on them, that was the included information, so ASA, versus two angles and then some other side, not the side that the angles are sitting on. That is AAS. That's the difference between the two. All right, I'm going to make my answer list real quick. The only thing we're missing of an angle is L, so I'll write that first, measure of angle L. And then our two missing sides, I go alphabetical order, side L and side M. The good news about this setup is you can literally solve these in any order you want because we already have the side angle pair, so we could go ahead and use law of sines, but I always solve for the angle first if I'm able to. It's the easiest and quickest calculation, so I get it out of the way first. Measure of angle L. Just like the last problem, 180 minus the two given angles. 180 minus 83 minus 5 degrees. 92 degrees is what's remaining. That is our answer. So angle L is 92 degrees. And then I'm going to split this up again. Now we need to find sides L and M. Again, you can go in any order you want, but I always go alphabetical. Law of sines. We have both K's, so we're going to use the K's in our proportion. Sine of angle K, big K, over little k, equals, I want L, so sine of capital L over lowercase l. Next, I'll fill these in. Sine of 83 over 1.2 equals sine of 92 over little l, which is what we're solving for. And you already know how this goes. I've already done it twice. Cross multiply. Sine of 83 times L is equal to 1.2 sine of 92. I'm not going to write out the dividing this time, but that is what I'm doing. L equals 1.2 sine of 92 over sine of 83. And then I'll use my calculator to get that answer. $1.21. Rounded to 2 decimal places. So I'll fill that in above. And now we just have to find M. Reminder, I'm still going to use the K's because they were given to us. There's no rounding involved there. And then I need to use M because that's what I'm trying to find. Sine of capital M over lowercase m. Sine of 83 over 1.2 equals sine of our capital M is 5, sine of 5 over m. And if you haven't already discovered this shortcut with proportions, allow me to show it to you. It'll save time. On quiz test, just for your own sanity and mine, I at least would like you to write out the proportion that you're using. I can understand you doing the math in your head, not in your head, but following it and then using the calculator from there. I'll show you how I do it. So without writing it out, the two that are across from each other that are numbers, those are going to get multiplied. So I could tell you without writing any of it out, the calculation is 1.2 times sine of 5 divided by sine of 83. I'm sure some of you already see that. So if you see that, that's fine. Use your calculator. Save yourself the time and space of writing it all out. But I at least need to see the proportion so I can see that you know what you're doing and you didn't just look off someone else's paper and get the answer. So that's all I ask. I will still write out the work, but if you do the shortcut from here on out, that's fine. I would do the shortcut if I were you. That would be me. Sine of 83 times m equals 1.2 sine of 5. M equals 1.2 sine of 5 over sine of 83. Then I just need to make one change in the calculator and I will have my answer. And this one's pretty small, 0.11. It's our final missing side. And don't be too alarmed at getting sides that are that small, or there are going to be times you're going to get very large sides as well. I'm talking 3 digits. Just make sure it aligns with the size of the other sides. If you get something ginormous and the other 2 are tiny, then you should be asking some questions. But looking at the other 2 sides, this number makes sense, so I wouldn't be too concerned about that.